Computers can only work with data in the form of binary numbers, so how do they deal with letters and symbols? Well, they use a different binary number to represent each character. There are two different systems that are used to represent characters using binary: ASCII and Unicode. ASCII stands for the American Standard Code for Information Interchange. The ASCII code for capital A is 65, and the ASCII code for lowercase a is 97. This table gives you an overview of the different ASCII character codes. ASCII uses 7 bits, which means it can support 128 different characters. The problem is, this isn't enough to support all the different characters found in all the different languages across the world. Unicode was developed as a replacement for ASCII that can represent all characters used in all languages. Unicode uses 16 bits, which means it can represent over 1 million different characters. Computers represent images using a grid of squares called pixels. A pixel is the smallest unit in a graphic image. A binary code is used to represent the colour of each pixel. In this simple black and white image, a 1 is used to represent a white pixel and a 0 is used to represent a black pixel. The number of bits used to store each pixel is known as the colour depth. The greater the colour depth, the more colours can be represented. This image only requires 1 bit to store each pixel, and therefore has a colour depth of 1 bit. The number of colours that can be represented can be calculated using 2 to the power of the colour depth. For example, a colour depth of 2 bits can represent 4 colours. The resolution of an image is the width times the height. For example, this image has a resolution of 5 times 6. The storage requirements of an image can be calculated using this formula. It's divided by 8 to get the answer in bytes. For example, the storage requirements of this image can be calculated using 5 times 6 times 1 divided by 8, giving us 3.75 bytes.